Hello everyone, welcome to this edition of the Software Developer Thursday. I'm really happy to have you here back at Noisteria. Since October 2020 we were doing it only online. Today it's a mixed version. We are also live streaming on YouTube, so everyone can follow us also online. Thank you to Tiago and Claudenir for being here. Tiago and Claudenir will present the implementation of the AlpineBits DestinationData 2021-04 of the Open Data Hub. So the microphone is yours.
Okay, thank you. Thank you, Stefano. Thank you all for your presence here. I am Claudenir Fonseca. I'll be talking to you about our implementation with the Open Data Hub of the AlpineBits DestinationData Standards, version 2021. So, just to start, present our team. We are the people from the university and in collaboration with NOI and the Open Data Hub, joining the effort of the AlpineBits Alliance to develop this standard. So, I'm Claudenir. I'm a PhD student at the University of Bolzano. I'm working in the project with Tiago, who is the assistant professor there with us. We are working under the supervision of Professor Giancarlo Bizzardi, and also with the support of our colleague Mattia Fumegali, research assistant. So, in order to understand this API that we have been developing with Open Data Hub, we need to understand what is AlpineBits and what is the proposal that that comes with AlpineBits. AlpineBits is an open standard to support the exchanging of tourist data in the Alpine region, filling this gap in the market for standards that are suitable for the specificities of the Alpine region. So the AlpineBits is governed by the AlpineBits Alliance, which is a group of SME operating companies working together to establish these standards and promoting them to be used among them and bringing other interested parts as well. They are all open. Everyone's welcome to come in and to develop their solutions and bring innovation to the tourist sector. So in that sense, the AlpineBits Alliance promotes these the meetings necessary, all the strategic part, and the maintenance of these standards. What are and why do we need these standards here? So we are talking about different companies that are working within the same domain, and a lot of the work overlap in the terms of the domains they are interested in, and in order to enable solutions, they work together to exchange data. But in an isolated scenario, each company is going to invest in their own solutions that are suitable for the problems they are trying to meet, and as a consequence, they are going to basically speak a different language. Their data is going to be suitable for their own needs, but will not be suitable to somebody else's. As a consequence, this increases a lot the value, the cost, in order to build interoperability between companies. So if you have a pattern that has some data, you have a second pattern that wants to present that data, but while consuming the data from a third one, the interoperability that has to be built needs to be built for each of these partners, because each of them has their own solutions. They have their own way of handling the data to their needs. And this is costly. This is costly because it's a lot of re-engineering to build interoperability. So what's the goal here for a standard? The role that the standard plays here is to define a shared language in a sense such that it eases the cost for companies to exchange data and as a consequence enabling new solutions, even new business opportunities. Because instead of developing interoperability layers between their systems for each, by developing it once, you are able to talk not to one partner, but to multiple partners, as many as implement the said standard. And it becomes a problem here, as in the it was perceived for the Alpine region a lack of options that are suitable for the tourist sector in the AlpineBits with its specificities. So the goal in the end of the day is to facilitate and reduce cost in this scenario of communication between partners. So, okay, I've been here talking about the tourist sector, but it's a really broad scenario. And in the end of the day, what are we talking about with a tourist data? We have two standards under the umbrella of the AlpineBits Alliance. We have a successful case with the hotel data standard, which is designed to support the exchange of data about hotels and bookings and availability of rooms, which is of great interest for the region, and which allows local companies to have the ability to offer greater value for their partners than some other parties that exist outside of the standard and outside of the region. So it brings in greater value for the ones involved and who know the demands of the locals. What we have joined NOI and AlpineBits Alliance in order to work on a new standard, the so-called destination data standard, that's going to cover the tourist data. So we are going into new domains and establishing a solution for data that was not covered before with new demands. So what we're going to cover? We are going to cover information about events, what events are available, what are the domains for events that exist in the Alpine region, and so all of the specificities to exchange data within the context of events, and and being supported by relevant players in the sector. We have the information about mountain areas. So about mountain areas, we have to speak about mountain areas, snow parks, slopes, lifts, and so on. What is available for as tourism options specific for the Alpine region? So what's the differential for the people here? So understanding geolocated data, the specificities of availability, and so on, and weather, and more. Things about snow data, and all of those. And then this is the domain that we strive to cover, and this is ongoing work, and it's always the opportunity to expand and to include all the demands that are recognized by the partners. And how we do that, how we work together how we join the effort to enable the development of the standard. So basically we have three main steps that we follow in our cycles that basically consist of development of what we call a reference ontology. So a model of the domain that describes in a way that all the partners can understand and can agree with one another what the data is about, what's the semantics of the data that we are dealing with. So this is the first step. We come in with the expertise of developing ontologies. We build these models that describe how the domain is structured. This model then drives the development of the actual data, the data format that's going to be used to exchange actual data based on the semantics that was agreed between the partners, given their requirements, their views on how the domain is structured. And later we define an API for this data to be exchanged. So in this case, REST API, how we can, and each of these I can go into how their responsibilities come into place. So the reference ontology defines the scope and the meaning of the information that's being exchanged. The data exchange schema defines how the data is structured, what are the field names, what are the formats, what we can expect, how we can express the information that you have. So we go into attributes, relationships, data types, how they are structured and there are many specific needs for the sector, metadata and so on. So we go into aspects of quality of data, what's required, what's not. And then we go into the API, which is the final step that defines how is the servers, what endpoints they are going to be defined, what are the requests that are available, the response, how they can be structured, how the exchange of data is regulated, the authentication, the error handling, the features that are required, and so on. So I believe that the best way to make it clear to what it comes to in the end of the day is to show the actual data being consumed in this open server, reference server that we have based on the data available in the open data. So I will go into now here. Just because the camera over there. So, what I'm going to show you is the actual. Yeah.
Can you guys see it? Can you read it? Yeah.
Better now.
Okay, can you read now?
Yeah.
Okay, so as I mentioned, we have worked with the AlpineBits Alliance to develop this standard that defines the model of the data, defines the data format. In this case, we are dealing with Json objects to be used to exchange the data, and we define a REST API. So, in the terms of a REST API, what we need to define what endpoints are used. So it's easier to navigate through the data regardless of the server that you are consuming data from. We need to define how you make the request. We rely on the HTTP and so on, and how the data is shown to clients and what you cover with the standard. Based on the standard, then we go into the actual implementation that's going to express what the server has available. So in the case of the Open Data Hub, we have the implementation of what you see here. is the request on the base endpoint of this REST API. So if you go to DestinationData.AlpineBits.OpenDataHub.pz.it and you make a request, you are going to get this object here that describes what implementations of it gives you links to access the actual data. So you have, this is largely inspired, if you know, we have tried to reuse as much as possible already defined and well-established standards. So we use here, you may be familiar with Json Api. So we use here, there is no data for this base endpoint, but we use it to show what versions of destination data you can access data for. So there is implementation of the previous version of the 1.0 that was released in April of 2020. And April this year, we have released this 2021 version, and we have additional links that are not mandatory in this standard, but there is flexibility for implementations to go beyond the standard itself and to cover their own domains. So there is also the Swagger documentation. And here I can learn that, okay, I have the link to the implementation of the version 2021.04. I can access it, and from here I will learn for that server what data is actually implemented. I can see here that in this implementation we have information about categories, events, features, lifts, features of resources, lifts, mountain areas, snow parks, and ski slopes. In order to understand, for a developer to learn this, how to navigate through this data, we have the actual documentation of the standard, the official documentation, but from the previous requests, we also have this over here, which is the documentation friendly to developers, which is we are using now Swagger documentation for you to come in and experiment with the data and see what is available and how you can retrieve the data. So,
Claudenir, let me just make a comment. So we want as much as possible that people who want to consume data from this API can do so without having to ask questions to anybody, right? So we want it to be as self-documenting as possible. So that if you just go directly to the endpoints of the API, you can navigate to see all the links that are available, all the endpoints that are available, and also all the different versions. And even connecting to the description of the API itself, which is what Claudenir showing now.
So while we have a full detailed documentation available on at AlpineBits website, all the resources I'll be sharing at the end of the presentation. We also have documentation that's more designed to be more friendly to data consumers who do not have as many requirements in order to interact with destination data servers. In this case, that we have an open endpoint, there is no need even for authentication. So if you come to the documentation, you're going to learn those two base endpoints that I have presented you, that are going to describe, and this is reflecting the implementation of Local Data Hub. So it's not going to talk about things that are outside what's available for clients. So in the base endpoint, we can understand that it's going to retrieve what versions are implemented in that server, and from the 2021.04 endpoints, we learned that it's going to retrieve all the available data. And this is interactive, so if you already know Swagger, you know that you can go to try it out. You can use the browser to execute the requests and retrieve live data. While this one below is an example, this one over here is the real data that was just requested from the server. So it's all already deployed and available for you to try out, for you to start to learn and think of new solutions that you may be interested on creating. So, in order to give you an overview of the data that we are covering, there are a couple of endpoints that are already available through OpenData Hub's endpoint. So we talk about categories. Categories are meant to have information about what the data is. So if I come here and I make a request, I think that's going to be more. It's going to be easier to see from the other view. So if you make a request for categories, so you're going to have resources describe information about other resources. So you can see here, for instance, the category meetings and lectures that is going to identify, in this case here, events. It applies to events, and with this you can know that okay, if there is a relationship from a specific event to this, you can display this to your user within a certain section or allow support navigation. We have information also about events. So in the case of events, we have here it's going to be. We have information such as a description of the event, the name, the URLs that you need, the actual dates for that the event is going to occur. We have information about what categories apply to that. So in this case here, it's a hiking tour. What images and videos and audio resources and so on that you have these multiple descriptions for a specific event, who is contributing to it, who is organizing, who is publishing, what's the venue, where it is located. We have all of these details powered by OpenData. Moreover, we have data about lifts. So, in terms of lifts, what kinds of information we have? We have for each lift also this basic information such as short description that we call abstract, regular descriptions, all text information, multilingual information. We have names, URLs, addresses, information about capacity, geometry of the lift, where it starts, where it ends, how to arrive, altitude, all of these specificities, and that you're going to see as I navigate through the requests.
Just one comment on this. When designing the schema, we try to be as consistent as possible. What I mean by that is that all the resources that you see, for instance, that Claudenir is showing, they all have very similar structures. So there's a set of properties, for instance, that are the same for all of the resources. So as you navigate through the API, you kind of learn a little bit about it. And then, if you go to a different API, if you go to the categories endpoint that Claudenir showed, you see that there's a name, there's a description of what that resource is. But also if you go to the lifts or the events, and so something that we really try to do is to make the life of the consumer, right, the developer who accesses this data, as simple as possible by maintaining as much as possible consistency on the data formats that we use.
On one hand, we hope to make the experience for the developer and the client more seamless when you have a lot of as much reuse of structure and classification as possible. But on the other hand, it also makes it easier for the developer to have a consistent developing a consistent solution, very well structured throughout its applications. Not only that, but it makes this is reflecting the demands that we have found in the sector here and that even though this is a demand that exists also in outside the Alpine region, in most cases, for most of the information here, we are able to capture the demands that are specific, and we are able to provide something that is not available open. So, as to the best of our knowledge, this open standard is unique in a sense of its coverage and its care with trying to answer questions that are common to multiple different applications and solutions. So when we talk about here lifts, we have to solve issues such as opening hours, how we describe opening hours in a structured way that has a level of quality that you're not going to be confused about. You can rely if that, if I can say it better, the provider of the data has enough expressivity to give you a reliable piece of information. So if you have a schedule, does that apply to every day? Does that apply to that specific day? Do you have exceptions for that? And so on. So these are questions that we have found to be necessary to answer the demands of the AlpineBits Alliance as they were presenting to us. And we were able to cooperate through the standard to provide solutions when they need to talk about those things. We have information about mountain areas. So in the case of mountain areas, you not only have the area itself, you have all of the lifts it contains, the snow parks, the ski slopes, the relationships to access the information about those, who is the area owner, and so on. And we have also snow parks and ski slopes with their own demands on in regards to difficulty, snow conditions, and things like that. For example, their own specific categories, their specific relationships and descriptions, and so on. From here, these messages that I was showing you, they are messages to retrieve collections of data. And we have, not only through Json API, for those who know this standard, we have tried to take as much power from the REST style as possible. So we go for a RESTful API, where you should be able to use hypermedia, you should be able to crawl through data using its links. So if you get the object that's describing a collection, you're going to have metadata necessary for that, such as pagination, how many pieces of data you have, how many pages you have, so you don't have to make a request for a very large data set if it's not necessary. You have the links to access the next page, the previous page, the last page, the first. You know what page you're in through the self link. And this is structured about metadata, about links, also is also applied to each specific resource as well. So if you go to a specific snow park, it's going to have its own metadata, such as who is the data provider, when it was last predated, what's the link to access that unique resource, the ID, the type of that resource, in this case here snow park, and also the attributes, which are things that information that talks about only that resource. That's not does not talk about other resources as well. So it's internal. It's data that does not have its own identification. And for data that's outside, that's in another resource, we have the relationships for you to know. Okay, this snow park has a relationship to two categories, piste and snow park, and we have this link to crawl and to access them. I'm going to show you in a moment how to take advantage of that, and you can simply you can do that programmatically, but you can click through the objects and navigate through the API. So if I go into a specific resource here to show how it is. So now you see that the structure for the endpoints follows this consistent standard, that's consistent pattern. You have the version / the resource type, and with a get request you get a collection of data resources of that type. With another / and the ID of that resource, then you get that unique resource. You don't get the whole collection. And moreover, if you use another / you can add the name of the relationship, and you can access only the resources related to that one. So if I go here to this ID / categories, I'm going to retrieve the categories that apply to that resource. In this case here, Loipen, cross-country, and classic, and skating.
And so this makes the API all connected, right? So you can navigate from different resources. You don't have these different silos that they are separate. They may refer to each other, but you don't have this clear connection.
The data itself seeks to be self-describing and also crawlable, in a sense that you can crawl just as you are in any web page. So examples of relationships that we have here, we have for a mountain area, I can go to the endpoint using the ID of the mountain area / lifts to retrieve all lifts that you can access, because there is this way that we use to know how much data you want to get. If you go for the resource, you are not going to get its relationships by default. You are going to get only the IDs of the related resources and a link to get that. There are features to help you minimize the number of requests that you need to make in order to retrieve more data. And I'm going to show those features that we have included into the standard later. But you can use the link to the related data to get only that. So if you're thinking about developing an application, a web-based application, an app or something like that, a mobile app or something like that, it is the way that you crawl the data is the same way that your user is going to interact with your application. Clicking to access more data about something, to load, if you're in a mountain area, I want to load the lifts, I want to load this lift that's located close to the place that I want to go to, and so on. You're going to be navigating through the data as demanded. For instance, for events, we can access the venues where that event is located. So I'm not going to get the event anymore in the relationship. I'm going to get only the venue, and the venue has what kind of information? Has mainly here the address, the geolocation, the geometry for that, and its own, if it's the case, if it's available, its own categories and multimedia descriptions. Multimedia descriptions, just to bear in mind, we use this to have any, these would be resources, not the images themselves, not the audio files and the videos, but descriptions with URLs for you to access that information, but text description, licensing, format, length, and all of those. In the case of categories, also as an example of something that we have a structure here, we are able to talk about categories in hierarchies. So if we check the category of educational events, this is a category. And this is interesting to highlight that was found as we developed the ontology and we talked to partners. Why do we need this complexity for categories? What am I saying about categories? You can think of categories as, in a simplified way, they would be similar to what we see as tags when you are navigating through a marketplace, as you are in a web store, or you are searching in any data browser. They are many times expressed as tags. Oftentimes they are even defined by users. And here we have found that very often we need to show not the tag itself, that's like a hashtag that the user wants to define. We want to show an actual name for you to display in your website, in your application. You want to have a description such that you are not confused between two categories. We want to know to what that applies, because it may not, you don't want to say that a snow park has, maybe you don't want to say that a snow park has rooms, because that's not what applies. So we have separated we have elevated the notion of category to something that has its own resource. It has a greater level of description, and these can be combined such that when I talk about the category Schema education events, which is inspired by schema.org. In the case of the Open Data Hub, there is their own category of courses and education, and this is a child category. This is a subcategory. So if I'm crawling the data, I may not be interested in crawling get me all the education events. If I do that, I also want all those that have the category course and education. That's specific to Open Data Hub, and you can structure with more sophistication. Moving on. Moving on. Okay, that's fine. We have shown a little bit to you. We're not going to cover all of the data fields that we have available, all of their implementations and the requirements that the schema allows us to validate the data. But we need more than the simple data sets to support the kinds of applications that we have in mind. We are talking about system-to-system communication, but many times you want also simpler web pages and apps to access and to be enriched with data from an open endpoint such as this. So what kinds of features we have found to be necessary to most of these systems, and these are features that we tell servers where they are not all of them required, so it's not as costly for a server to be implemented, but they give you an answer to how am I going to implement these very recurrent use cases. So we have incorporated into the standard a solution for pagination. So can you see this bit over here of the request? Okay. So we have defined the parameters for you to add to this request, to this, basically it's a URL. You can fill this into a web browser. We are going to do that later. You can say the page number that you want and specify a value, and the page size that you want. So you're going to divide in many pages your collection, and you're going to get a specific page of that. So in here I have requested for the page to end of the collection, and I want it to be divided in pages of only one resource. So my the Open Data Hub's over 1,100 in this case here is ski slopes. Each page has only one. Here, if I check the self request, it's informing me that I'm on page 20, and the links, such as the previews, is going to send me to the page 19 and to the page 21, and I can click on this to navigate. The next feature that we have incorporated is regards to field selection. So if I expand this a little bit, if I see that a request has too much data for me, I can also request, okay, I only want these specific fields. You use the parameter fields. You mention what resource you're talking about. In here, I talk about the fields of lifts. And out of this, I want the name and the geometry. And this is exactly what I get from the resource, and everything else is excluded from the request. We also have the inclusion. So if you, okay, I go now, I get the event, and later I have to go again to get the venue. I want everything at once. I know that I will need both of them. We have the inclusion. So in the case here, I'm asking for mountain areas. For this specific mountain area, I want to have the inclusion of the lifts. So you're going to include a relationship. The resources that are found in that relationship. So instead of having the link to get that later, you have the resource itself. So in here, you can see that there is in the data field, I have the type, and I have the ID of a mountain area, but also we have the included array, which has each of the lifts for this mountain area. The next...
Just a comment on this one. This is also, this is very useful because first it reduces the number of requests that we have to do. So if you want to get the mountain area, then navigate and get all the related resources, you can do that all at once. Right? And also if you have a collection, let's say, where I want to list all the mountain areas, you want all the related resources of those mountain areas as well, so all the lifts, all the trails, you can get all of them at once without any duplication. And so it really simplifies the whole thing when you want to actually get a lot of data at once.
And actually, this brings into question something that we found very interesting about the nature of developing the standard itself, which is we have to question every decision that we make because we are coming from a blank slate, basically, and we want to deliver the best standard for the members and the demands that they need. So we have investigated options such as remote procedure calls. We have investigated REST. We have investigated more modern solutions such as GraphQL. And in REST, we have found the best compromise in terms of ease of adoption and consistency, and basically these metrics that were more fundamental to us. But at the same time, we have to recognize the limitations that the REST API has. And we have to work towards mitigating those limitations. So the inclusion feature is one of the solutions that we have to mitigate this demand of having multiple requests when you have REST API. You have to make more requests than with other approaches. The other solution that we have is the relationships and the hypermedia navigation that allows you to crawl the data, so it's easier for you to, if you have to make multiple requests, then you're going to be supported by the actual data that you just retrieved. So these are technical solutions to cover as much as possible and mitigate as much as possible the drawbacks of any adopt standard or technology. For the hour that we are in, I have to go a little bit faster. So we have other features of this. I would say that the most notable is the filtering. I'm sorry, in here in this file I have probably removed the filter, but I can show to you. Okay, I have a filter here. So in this case, I was showcasing the parameters to sort data. So for events, for example, it's very important for us to be able to sort data based on dates and so on. So we have a parameter for that. And I have added to this request here, I have added to the request a parameter to have lesser amount of attributes, just to be easier to show to you the information about dates. But I have filtered here the data based on the start data value, and we have two solutions for filtering. One is you can define your specific, as a server, your specific filters based on the name, but you can also reuse a generic solution that we include into the standard, such that you mention what's the field that you want to filter for that resource that you are requesting, for that collection that you're requesting, and an operand to say, okay, here I'm saying I want start date to be greater than 4th of July. So if you have the interest to go in an event in the next days, based on the information that we have now live from OpenData Hub, let me see. You have the opportunity to visit the Esecuzione guidata della via ferrata SAS Regiais a 3000 metri. This is real data. This can power your solutions. This can enrich the application that you already have. It's already available. And by the way, any feedback is more than welcome.
Just a comment on this filtering scheme. This is something that we debated throughout many meetings, right? Because it was about deciding whether to go with very simplistic approach. Each company defines their own schema for filtering, or go to something generic that everybody should apply. And it is not as convenient as others, let's say, architectures. Because if you're using GraphQL or if you're using Sparkle, it would be a lot simpler. People can just write their own query, right? But here we adopted this convenience and this, let's say, low entry barrier of using an HTTP API over JSON. So then our middle ground was to define this convention for filtering, right? Based on fields and this keyword for defining how you're filtering the actual data.
Thank you. So I'm afraid the time is going to be short, and some things that I would like to point you is I need to go a little bit faster here. So regarding filtering, we saw this discussion, and the approach that we have, by the way, is very similar to what you found like in MongoDB and the document databases, JSON, where you express the request as JSON. There's a lot of inspiration here based on that. But it's not our intention to impose too many design decisions onto servers. But we have this concern about if there is a problem that is shared by many use cases by many partners, we are able to give you an answer that you know that a whole community of data of clients is going to be able to understand and consume, and is going to answer questions that you are going to have trouble to answer somehow. And if you don't have to develop a design in-house, you can rely on the destination data standard for those use cases. So many of these that I'm showing, it's not required for you to be a destination data server to implement, but if you want to cover that, there is an answer for you. And if you have other use cases, it's being developed actively with at the moment annual release. So the discussion is great. Another thing that I think there are two other points that I judge to be great value incorporated to the standard. We have I have a great concern with how to handle errors. So not only things such as 404 not found, but even beyond that. So if you request a page that does not exist, that is like beyond the number of data that's in your collection, what's the approach? And we go for an approach that we value data quality, we value reliability. So the server has certain responsibilities. In the case here of we have the example of page not found, we incorporate a number of error handling to be standardized for many cases. But here, when I try to request a piece of data from a page 200 that does not exist, I will get an error. Not only the 404 not found, which is required by the standard, but the standard also informs you how can you make the experience for the client better. You can provide this client with a JSON object in the same format that you have for the actual data, you have for the errors as well. You treat the errors as resources themselves. You mention, you give a title for that. You give a description that's not, these two are human readable, but also specific to the actual error that occurred in that instance. And for the pagination, we are able to also add links. Okay, you made a bad request because you don't have that page, but if you want to access, you have these links to the first, the last, the next, and the previous pages. And you also have the metadata about how many resources are there. You don't have to make a second request to know how to fix. You don't have to go, okay, I went to the 200, 200 does not exist, I have to go back to the first to know what's the last and make the request again. The error is actively trying to help you as a client to, if you are a human user, you're able to read and understand. If you are a piece of software, if you are a software agent, then you can use this to navigate and self-correct mistake.
Yeah, something that we really didn't want to do is, I don't know if you have this experience about interacting with an API, that you send a request and you get a 200 OK, see if everything is working, but none of your parameters are actually taken into account. So our approach here is that if the user sends something that for any reason the server cannot handle, we will let you know. Right? We'll never give you a 200 OK if there's something wrong with your request. Right? And we'll put this error code within the HTTP header, but also we'll incorporate, as Claudenir was showing, this nice object that will give you more information on how to, what actually happened. Right? Did you set the name of the field wrong? Right? Or did you set an invalid parameter? Or are you requesting the wrong endpoint? To give you this information so that you can easily recover and you don't get frustrated. Right? We're trying to, as much as possible, reduce the frustration levels of developers that it will interact with the API.
In other words, we try not to accept silent fails. You cannot fail silently. You have to let your client know that there is something wrong with that request. If you make a request, for instance, let me show you here. You ask, okay, give me this field here for lipids. I want the field organizer. There is no organizer for relationship for events, for lift, sorry. So there is a message there. Some of the fields that you are trying to request, they do not exist for lifts, and this is the parameter that broke your request. This is a 400, so it's a bad request, it's the client's fault. So there's a lot of information there, and it's not expensive to implement this, and to being standardized, it's not costly for you to figure out how to make this work. And a last piece here that I really would like to show you is that we also answer how to deal with important data types in these data structures. One particular data type that I like to share is about scheduling information. When a certain place is going to be open, what are the exceptions for the schedule? So we have a structure answering that because you have weights, you have standards that speak of opening hours. But we have not found one that went to the level that give you reliable data where the provider can tell you, this is the usual opening hours for the calendar for this specific place. But there are exceptions on these days, and these are the exceptions. It's going to be closed, it's going to be open, but at this different time. And you can find this on the standard, and we are pretty proud to be working with that. I would like to show you how to navigate through the data. So let me see, 5 minutes. Okay. Yeah. I would show you that you can basically, okay, if I'm the standard here, I can go to the version. From the version, I can go on the link to the mountain areas. The mountain areas, I would like to see the last page. Okay. On the last page here, I like this. Let's see, this mountain area here. Let me see about this. I want let me see. Okay, give me the lifts. There are two. I want to know about them. You can click on those. Oh, nice. There are two lifts. This lift here, it has what categories? Okay, this is a telemix. Let me see those categories from the telemix. There is something nice that I like to show as well. Okay, this category, maybe this is not going to... Okay, it's better if I move on to the final point and I open to questions as well. I have shown you the standard, and you may be asking yourselves, okay, but you are from the university, what is your role in all of this? Why you have joined the project? We have joined the project because our expertise is on the development of ontology, of these models about domains that describe how different stakeholders share the semantics for a domain in a consistent way. And from this expertise that we were able to bring into the discussion table with the AlpineBits Alliance, we are able to drive we are able to do two things that are really important for the standards, and for any standard that matter. We're able to establish a shared meaning between the stakeholders, so they agree on what they are talking about. When we're talking about an event here, we're not talking about an event as a record or something that happened in the past. We're talking about a plan, something that's going to happen, something that has the involvement of organizers, publishers, has sponsors, has a venue where it's located, but it can be cancelled. It can change. It's something that it's a plan that's shared by all of these people and all through some community. We are able to use our expertise with a ontology language that we call UntiML, that helps you to build consistent ontology based on very mature philosophical and scholarly theories, on cognitive psychology and so on, to drive the reliable and shared semantics of the domain. And something that's really interesting from that, this is really important for any standard to have agreement, because if you don't have agreement, you don't have a standard. The agreement drove the development of the system itself. The ontology that we have this model through the questions that the language, this UntiML language that I'm talking about, that you can find in the standards, in the documentation of the standard. Through the questions that the language drives us to answer in order to build the model, we are able to make consistent design decisions, reliable design decisions, because we're able to understand, okay, we have events. We have events and we have agents. We have identified these two different kinds of objects, in a sense, in the domain. These are different endpoints. These are different resource types. But okay, there are relationships between these two. An event agent can be organizer, can be a sponsor. But these are things that are dynamic. These are things that change. So a better design decision was not to make a resource type for that, something that has an ID that I'm going to construct and construct again. I have a relationship for that. If the event is able to be cancelled, I have like scheduled, I have ongoing, I have past. These are attributes. These are not relationships. These are not resource types themselves. And these kinds of design decisions, they can be made wrong if you do them in the wrong step of your development. And we believe in the role of ontologies driving the agreement between stakeholders, which is central for any standard, but also for any system, as you are going to provide a solution for some client, and you have the interested parties as well, so it's applicable to any case. But it also applies to actual code, to actual design decisions, to actual choice of architectures, and so on. So this is the message I wanted to show you. It's exactly 7:30, and if you allow us, we can have questions. I'm sorry for taking all of your time, but thank you for your presence. By the way, just before we finish, I have to thank some people here. I cannot end without saying this. I have the standards here, the resources that we asking them to be shared. I would like to thank Noi for inviting us to join this effort, and AlpineBits Alliance for having us at the table and allow us to to build this solution that we are very proud of, and specifically to thank the people of that work directly with us inside the alliance, that are Martin, Stefano from Park, Good from as well, who helps us with the Open Hub API, and Emily, who makes us the checks and balance to make sure everything works. Thank you all.
Thank you. Thank you, Claudenir, for your nice presentation. So now it's question time, or if you have something that you want to say. Now we have still at least half an hour time, so we can discuss.
I misunderstood.
Don't worry. So if someone has a question, please raise your hand and don't be shy.
If you allow me, I'll go into more details. Just because I thought that we're ending now, not 80.
No, we are planned till 8 o'clock. So if no one has question and you wanna, Matthias.
How was the original AlpineBits effort integrated with your work? Since it was about an XML standard.
Okay. So this is an interesting question. When we go, so for those who may not be able to,
can you repeat the question?
The question is regarding the existing standard of AlpineBits, which is an XML-based standard for the exchange. I mean XML in the sense of the hotel data, which is exchange XML data about accommodations and booking information. This is a new effort for a new set of domains. So the alliance was open to a solution that was suitable for this new challenge that were being investigated. So we had like a blank sheet to work on, and we were able to reflect on the experience that the alliance had during the development of hotel data. And with that input and with the input from the investigation that we have made, we have been developing these new solutions with a new set of technologies. And actually, we were able to fill a gap that existed in the first also from our expertise. This is the way we view the issue. We're able to help them with the process of standardization of semantics, of meaning, because this is the role that the ontology plays. When I talk about ontology, these are basically conceptual models. I can show them here. We build them in a format that is familiar. If you are familiar with UML, in the end of the day, for you can read the models in a very similar way. As soon as it allows me to get there. Okay. This is, for instance, the portion of the ontology regarding event plans that we call. We don't call them event plans for the clients. We call them events as the resource types, but we say that there is no way you cannot have an ontology. There's no way you cannot have a shared model of meanings. What happens when you think that you don't have an ontology, when you don't have a model, is that you do have models that exist in the minds of the different stakeholders. And these models, because it's basically how they view the domain. If you are not making that explicit, they may disagree. There may be points of conflict that, as a result, if you don't make that explicit, that if they are not able to foresee these points on this early stage of the standardization that we try to fill this gap with the destination data with our work on ontologies, what happens is that you have a standard that's not suitable for some domain that someone was intending to solve, or it's very hard for you to make it compatible with some implementation that has a different view, because the stakeholders, the partners in the alliance that are developing and driving the implementation of this standard, they're not able to communicate and make it clear for one another what are their views.
I remember in the first meeting, I don't know if you remember as well, Stefan and Emily, you're both there. None of the partners agreed on what an event was, or what properties an event should have. Right? From day one, nobody agreed on what it was. So what we tried to do is first agree on what we're talking about, was our confusion between services and events, and what would be one or the other, what properties an event should have, and so on. And then we first established this agreement, then we went on to the, let's say, the technical solution. And just another comment on the hotel data, the first initiative. A lot of the members that participate in this initiative were also there in the hotel data, and they bring a lot of these expertise and the experience that they had. So some solutions or some problems they were facing that were similar would just use their experience and apply to this slightly different context. Because at the end of the day, although we use JSON in this one, I mean, it's still hierarchical, still is just a little less verbose, let's say, right? So we reuse a lot of their experience from there, right? We weren't there in the hotel data initiative, but with a lot of the members, the partners that participate in the meeting were, so they really bring this on, and we reuse a lot of this. But it hasn't been formally integrated, right? They're still, let's say, separate, but maybe Emily or Stefan can say a little bit more about this.
I can say another thing, that hotel data is based on OTA standard, so it's different from this. We don't have any real standard on destination data, so we are not based on OTA. So we had to do a step back on this. And in hotel data, we have to deal with OTA standard. So this is the main difference.
And I can add also a comment on something that sometimes that concerns some on when you have like organization driving the development of standards, which is standards that reflect specific views of vendors, and that happens in some large organizations in the market. But when you have something such as an ontology, you expose the views of the ones developing. So there is an aspect of fairness when you have the explicit development of a shared model, and there is an aspect of and there is a lot of we are not coming up with everything ourselves. We're not trying to reinvent the wheel here. What the process that we undergo is in the development of any new data set, let's say. We're going to sit with the members of the alliance. They are going to bring in what they see as important things to be discussed in there. We're going, for instance, to take a new domain. Then we are going to investigate if there are standards on there, open standards, if there is something that we can rely on. Oftentimes we go to, for instance, Schema.org that has this concern of making supporting structured data in the web, and then we're going to see, okay, we have these solutions that are available. They have some overlapping with the domains that we are working on. Is this enough? If this is enough, then we can try to reconciliate that in the structure that we have. So, for instance, for the categories of events, we incorporate all categories from Schema.org. But for events as a whole, there are many demands that systems, or actually supporting solutions such as an app, such as your app, then your phone, or even their websites, when you have that as a product, things such as Schema.org or other options that we found for other scenarios were not sufficient to support the needs of the people implementing the solutions. So we diverge when we need to, we use when we can, and we promote all other operating standards as the one that we are working on. One case where we have completely incorporated another standard is in the case of how to handle geolocation. So we have GeoJSON as basically incorporated into the standard, and we don't have to answer that question anymore. But for, as I was saying, opening hours on a place, on a venue, on an event, on a lift, we didn't have a suitable solution, because other solutions that we had found, it was not possible for a provider to make it clear for the clients if someone was indeed expected to be open or closed. So okay, we have found some options. They were able to express like what were the, let's say, if you take the structure that I guess Google Maps uses, Google Maps, you can see on Google Maps. You don't know about exceptions. You're not really able to express exceptions with ease. But then when you're talking about events here, we have a lot of exceptions. We have exceptions for holidays, for festivities, and so on. And this becomes something important for these tourist regions, these alpine regions. Another thing that we have developed, I don't know if how much you have reused of other solutions, is our solution for textual information that's multilingual. The Alto is a really special region in the sense of the many cultures that bring this together. And when we are talking about language, this becomes really relevant for us to be able to communicate with these different communities in different languages. And the data that they are, and one thing that we believe is, if you give the means for people to express themselves in a consistent way, they are going to give you the data that you need, and that's going to become a value. And we reuse. We have here this here. Okay. Let me show the text information. Another request. Let's see if this guy here has an answer. When you see here description, any text information is not just a string of a set length. It's actually an object. And the tags, they are language tags based on ISO standards to describe, okay, which language this text is in. So if you are in your app, you can easily support, the user can decide which language they are going to find that information. Even for URLs, even the URL here, URL field, even the URL field, you can find a website. If it has different language, maybe you can have different, because this piece of data, it has not the website does not offer different languages here, but you're able to express that information too. And this is not something that we have found easily. But on the other hand, if you are going to build your solution and you need to deal with multilingual information, there's an answer for you essentially. There is a lot of value on data types, and a lot of really interesting thing that I think that's part of, and this is something that we have brought in. This is a combination. We have brought in Json API. So this is a standard for how to structure JSON objects for REST API. So when you see here links, meta, attributes, ID, relationships, these things are part of JSON API. But JSON API does not tell you how you see if a piece of data is an attribute or a relationship. You could very well model the categories as simple text and they are just strings and you move on. But we have found that to be a relationship with actual resources that describe those tags, that describe those categories. And this is something that it's a design decision that emerged from the ontology that we have built at that early stage. So the development process for the destination data standard largely consists of the cycles of we select, or it's very clear for when we are going to a new data set. We select a new data set to be incorporated. we investigate what are the requirements, what are the demands, what is available. We model what's the view of the stakeholders. They can tell us if there are differences between how we have modeled and how they see, how they actually manage that data. And then that drives the development of an endpoint, of an API, or new features such as new filters that are specific for that. Because if you do not have events with their start and end dates, maybe the sorting feature will not be as relevant at the moment, and it would be incorporated in a later moment. So it's a very reliable cycle for you to work not only with applications that are within a single company, where you have to talk about like how you're going to harmonize the needs of your clients and the views of your partners, but also even more in standards when you have actual separated partners trying to share their views in a shared language. Other questions? Questions from our friends online? Maybe not at the moment.
Not at the moment.
Talking about events, do you think of taking care also of big events such as Olympic Games or I don't know, biathlon games or something like that? Or just the event of normally take place every year?
So the question is how large is the scope of events in the model that we have built and the solution that we have built. Our way to talk about event plans, billions of things that have not happened yet, things that are planned, may have happened, but not necessarily. We register them as plans. It's consistent for you to talk about as something as small as this meeting here. I could have said that there is a title, there is a description, there is a place. But I can also use composition. I can say that events have sub-events. So if there are the Olympic Games, there are many events within the Olympic Games. They have their own venues, their own dates, their own schedules, their own descriptions, their own categories. And the solution that we have built, we have worked towards making it as broad as possible for all demands in terms of event planning, but as easy as possible for you to talk about different size
Maybe the biggest one that we have here, I would say in this data set, is the Sul-Tirol Jazz Festival. I mean, something that happens every year, has some multiple concerts going on at different places. So we designed from the first, let's say from day one, to be able to handle any size, right? Whatever it is, that is going to be.
Oh, by the way, something that I have not discussed, and it's in the actual title of this conversation here, this meeting, is, okay, we have destination data and we have Open Data Hub. How those two things work together? Open Data Hub is one of the partners. Sitting at the table of Noi, is one of the partners. Sitting at the table of the AlpineBits Alliance. It's one of its members. And they are actually a data provider. They are data providers. They already have this work of being a hub that collects data in the region and make it and basically has this huge effort to integrate the data and make it available in a single place. So even though it's a destination data for Noi is something separated from the APIs they already have, so they have a large sets on IoT information and all of these things that we are consuming here and even much more they are able to provide in their own API. But it's in the nature of Open Data Hub to it's only natural for them to work with destination data because now they don't have to define the schemas themselves. They can understand how this data can be best understood by the clients for a hub. So we are happy to be able to have their APIs as a data provider for us. So what we do is, in order to prototype and show how the standard works in the end of the day, and not being only as a toy examples, we were happy to be able to consume Open Data Hub's data in order to develop what we call the reference implementation. So there is this open endpoint, which is built as an implementation of the destination data, which has real data, and it's lively updated. You can go there, you can find the things that you're going to find in the websites of the autologic region. So it's, in a sense, a different way to access a portion of the data of the Open Data Hub, but it's Open Data Hub commitment to the destination data standard as the first implementers. We have the data standard as open, so anyone can go and build their own servers. We have solutions about, we have not talked about here, but how to have shared ways to do authentication. We also do not limit how standards, how implementation must be. They can go even beyond the standard itself. But with this reference implementation provided by with the hub of Open Data Hub, clients can already go and try it out and try to reach their. If you have a solution now, you have a use case that you would like to experiment with Open Data Hub, there is open data there for you to consume and to think of new solutions that we would love to hear about and see this thing take shape and evolving. We have other partners, and we are promoting the standard for new servers and new clients to come in. But it's an invitation. It's an open community, and we are here to actually invite you, in the end of the day, to join us in this, into building new solutions that can show the value and innovate in the tourist sector. We basically make new possibilities. Okay, we are closer to closing time. If you want to say something.
Thank you, Claudenir and Tiago. Are there other questions, or someone wants to say something? Claudenir already said that Open Data Hub is using the destination data standard to publish the data about events and mountain areas. We made the first demo implementation that you can find on our GitHub repositories, so you can look at it. If you want to replicate it, you can contribute, fork it, make us some issues if you find. So if you wanna, you are welcome to contribute with us to develop and go further and make other further steps with the standard definition, with the Open Data Hub definition. So don't be shy and contact us at info@alpinebits.org to get in touch with the AlpineBits Alliance, and help at opendatahub.bz.it to get in touch with the Open Data Hub team. So if there are no other questions, I'm really thankful to Tiago and Claudenir for being here presenting what they did in the last year. It was a great job, great presentation, so thank you. It was a pleasure to have you back here at Noetech Park, to see you. It's another feeling to make events here and have together a beer and discuss about technology, so I'm really happy about this. The next Software Developers Thursday will be the 5th of August, and URAC Research, the Sensor System Technology Lab, will make a presentation about Keycloak and how they use Keycloak in IoT projects. So if you are willing to come, feel free to register on Eventbrite. You will get a reminder around the 15th of the month from my email. So thank you to everyone for being here, and I hope to see you soon.